Perkinson's been helping out. Rao has been teaching abstract algebra the past year, so he's going to tell us about his experiences at Reed with Sage.
Good morning. Again, I'm Rao Potluri from Reed College. We're one of the test sites. For the first time, I used Sage this last spring in my abstract algebra class. I'm not an expert on Sage. I started learning just last summer. I'm a little bit better than a beginner, but not much better. First, about the class itself, it's a junior level class. Most of our math majors, they would take this class as either as sophomores or juniors. And during senior year, we have additional 400 level algebra classes. In this class, well, I used 2 books. Tom's book is available for free, Tom Jerson's book on the internet. That's been very good, especially for Sage. I also, because Tom's book is free, I thought it's not too much of a burden for students to get a hard copy of Galleon's book, which is also a very popular book, just so they will have some additional examples, additional applications, and so forth. I'm quite happy with both books, and I didn't get any complaints having to look at both books. My class had 15 students this semester, 4 sophomores, 10 juniors, and 1 senior. A couple of math physics majors, and 1 math philosophy major. The rest of them are math majors. I would, of course, give weekly assignments, maybe about a dozen regular kind of exercises, and 4 or 5 Sage exercises. Sage exercises are mostly from Tom's book. Tom has, I would say, some kind of practice session on Sage commands, relevant Sage material, and then he will have some 5 or 6 exercises. I did make up a...
Rao?
Yeah.
You're not using your slides.
Oh, okay. Thank you. Yeah. Thank you. Okay, yeah. We already talked about this. Next one. Yeah, I would give them about a dozen problems and about 4 or 5 Sage exercises. Sage, of course, is not prerequisite. Knowledge of Sage is not a prerequisite. So I didn't think it would be appropriate to make it mandatory. So I told them that I highly encourage them to use Sage. And by way of incentive, I told them that if they're doing a decent job, at least make a good faith effort on learning Sage, I would give them some credit. For example, if they were getting a B, their grade would be B+. Some extra credit for using Sage. But if they don't use Sage, I won't penalize them. B will stay as B. I don't know how fair that is, but I thought that was okay. I didn't hear any complaints. I guess they were too polite to complain. So let's see. In the beginning, I would basically repeat what Tom has, just for a few minutes, going over some Sage commands. Yeah, the next item, Sam Hopkins. I was very fortunate that we had a senior student by the name Sam Hopkins. He's really, really good in Sage. So I hired him for a couple hours a week, and he would be available in the evenings. I will also be there. Students can come and ask Sage questions. That turned out to be a wonderful thing. Sam was very good. And I asked them to turn in hard copies of their notebooks, the SAGE exercises. There's probably a more efficient way to look at them. I think Rob, for example, does everything on the computer. But I wanted hard copies of worksheets. I would give them to Sam, so they would turn them in on Friday, and Sam would look at them on Saturday, and then I would come in Sunday and look at them again. So I could see his corrections, and I will also learn a few things that I didn't know about. So that worked out quite nicely, I thought. 8 of them are familiar with SAGE. 4 of them are, in fact, quite good. There's one guy who's really, really good, just like Sam. And 7 of them are new, and 5 of them really tried to learn, and 2 of them didn't want to bother. So that's what happened. Okay, I guess the main point is, the main item is what worked. I was pleasantly surprised, and in the end, I ended up giving 5 A's, 5 B's, and 5 C's. So it was a pretty good class, slightly better than in the usual class we had. And a couple of students who were pretty weak in algebra concepts, they really liked using SAGE because they developed a little bit of a confidence. They felt like they were really doing something because they would discover a few little things by playing on the computer with SAGE. So that gave them what I thought some kind of confidence, psychological lift. It just made them feel good. So that was pretty good. And the second item here, we would, of course, in the exercises, we would, of course, ask them to make some conjectures by putting in various values of some integer and then discovering some statements about that. And what I discovered in the end was that the results that they discovered using SAGE, even though they didn't prove them, they remembered them much better than the results that I would routinely prove in class. A good example of that, I think I'll mention this later, this group of units mod n, so-called UN, group of units, after some experimenting, they discovered when that group is cyclic. And later on, in some other problem, something like, and I mentioned 13, which is a prime in the integers, someone quickly said, oh, it's not a prime in Gaussian integers. So I was pleasantly surprised that they remembered that so well because they played with it for quite a bit. Okay. Now the third item, I think it's an important item that I want to talk about. I have my syllabus laid out, and certain topics I didn't plan on covering because it's only a semester class and you can't go on doing everything. So what happened was the SAGE exercises naturally led me to some concepts and topics that I didn't plan on covering. Let me illustrate what I'm trying to say by a couple of examples here. I defined what an automorphism is, and I gave some examples and the usual stuff. And in one of the exercises, they discovered that there are 8 automorphisms of the dihedral group of order 8. 4 rotations, 4 deflections. And of course, they have this basic theorem that group on the center is isomorphic to the group of inner automorphisms. But there are only 4 inner automorphisms, so they know that. So immediately someone asked me, how do I find the other 4? I was pleasantly surprised to hear that. So we started talking about maybe we can come up with one automorphism that's not even an automorphism. So that led to this basic question: how does one define an automorphism of a group? How does one construct one? How does one begin to think about finding an automorphism? I thought it was a wonderful discussion. So we had a nice discussion. Well, pretty soon, of course, students will start saying things like, oh, we should map any element having a certain order to another element having the same order, center must go to center, and things like that. They would say, okay. And before I knew it, we were led to this idea of generators and relations. So a natural way to define an automorphism is to, if we could, come up with a so-called presentation of a group, and we need to map generators to generators and relations to relations. That would give us a homomorphism, and then if it is on true, then we have an automorphism. So it's a whole new chapter in this in the book. I didn't plan on covering, free groups, presentation of the group. So I ended up spending two classes, maybe a little bit more, and we talked about that chapter. So that was wonderful. And using that idea, in fact, they discovered that the number of automorphisms of Dn. Dn is the dihedral group of two n elements. Is n times p. They checked that they can map any reflection to any other reflection. They can map a rotation to a certain, say, a power of rotation, where the power is relatively prime to n. And they checked for all the choices, they generate and their corresponding related poles. So that turned out to be a wonderful experience. Here is another very simple example, much simpler. That led me to talk about something that I didn't plan on talking about. I asked them to find the number of conjugates of this element in Sn, and they know the basic theorems. Conjugate permutations must have the same size and structure and so on. So they did that. But then they also have this theorem that the number of conjugates in the index of the centralizer, so they know that. So for example, in S4, the centralizer of this product of two cycles has 8 elements. They figured that out. So I asked them, what kind of a group is that? And some of them used Sage, some others guessed. They said, oh, it's a dihedral group of order 8, which turns out to be correct. So the natural tendency, well, as soon as they hear dihedral group of order 8, they will say, oh, it must be rotations and reflections of a square. And that's great. So the natural tendency is to label the square in the natural order, like 1, 2, 3, 4, like that. So then, but if they label like that, for example, the transposition 1, 2 is not a symmetry of that square. Because you can't fix 3 and 4 and still do 1 and 2. So for a couple of moments, they say, oh, something is wrong here. Then, of course, it didn't take them long to relabel the square in a different order, which is 1, 3, 2, 4, and then every permutation that commutes with 1, 2, 3, 4 corresponds to a symmetry of the square if you label it this way. So then this idea, this notion that two groups can be isomorphic without being so-called permutation isomorphic. So in this case, this notion of two groups being permutation isomorphic came up. We all know that two groups can be isomorphic without being permutation isomorphic. So that's something I didn't plan on talking about. So that was wonderful. And just to mention a couple of other examples where we had very extensive, very helpful, lengthy discussions are these problems. For what n this group of units is cyclic. That's a hard theorem to prove. They didn't prove that. I ended up proving it, but they discovered it. Not everybody discovered it, but some of the good ones discovered the correct result by using Sage. And the Gaussian integers mod and a principal ideal generated by A plus BI, how many elements are there and what's the characteristic. They're not obvious, but Sage, by using Sage, they discovered that. Primes and in the Gaussian integers. This is another nice problem from Tom's book, I think, for what x, the transposition 1x, and the full cycle generate SF. Sage, by using Sage, they discovered that. While we have these discussions, of course, some of them would come up with the wrong conjectures, which is what you would expect, of course. And then they would ask for a counterexample. That was hard for me to do that. It's not easy to come up with counterexamples in front of the class right away. So, that was good as far as learning goes. It's nice for them to know that I don't have all the answers. But of course, I would think about some things that I couldn't answer, couldn't come up with counterexamples right away. And next day or maybe 2 days later, I would come up with something. So that was wonderful for me. They appreciated that. Okay. I said complications, maybe that's not a right word. Just some things that I should mention. Probably I've got a little bit not very comfortable. Okay, as I said, if they make a good faith effort, I would up the grade a little bit. Some of them who are not so good with computers, they felt they didn't have that opportunity. Or nobody complained, but I sort of sensed that they felt maybe a little bit discriminated or something. I'll talk about this again, but it would have been nice if all of them knew at least all of them had some knowledge of Sage before the course began. And some others, they just love to work with the computer all the time. Yes.
I have a question. You said that some of your students had experience with Sage.
Yes.
Where did they get their experience with Sage before your class?
Oh, that's a good question. Some others, Dave, for example, as well as a couple of my other colleagues, they were using Sage in calculus and other places, number theory. We have an elementary number theory class for freshmen. Yeah. And I don't know where they learned, but some of them learned even before they came to read. In high school, they used Sage, I guess. And like I was saying, a couple of students were spending way too much time with computers, and not enough time with theory. They would have done better if they would spend more time with reading the books. And some of the exercises, they were good exercises, but they needed being able to write some simple code, simple programs. And so some of them were a little too hard for them. Again, I was using this for the first time, so I hope to come up with better exercises. So for next year, again, I was saying that it's better if they had some kind of a crash course in Sage before the course began. In our at Reed, physics department requires Mathematica to all physics majors. And to sophomores, they would teach Mathematica for 2 or maybe 3 weeks, a crash course. So everybody must learn Mathematica, physics majors. Something like that would be great if we could have a crash course in Sage. I don't know how we're going to implement that, but I thought it would be nice if we had such a course. Better exercises. So now that I have some experience with exercises, I know how capable the students are, what sort of problems come up when I do these exercises. So next time I teach, I hope to spend some time designing better exercises. Cheat sheet for groups, rings, and fields. There are some cheat sheets available already. I know Rob has one for linear algebra and maybe other things. Of course, we all know that you can get a lot of commands by pressing the tab or something. For example, if you type a matrix and then hit the tab, you can get a million kinds of commands you can do with the matrix. But it takes some experience to know which command does what, and so they can quickly use that. Anyway, I thought it's nice to have a hard copy, or at least something on the internet, something called a cheat sheet, so they can look up various commands very quickly. And then I had the students fill out this online evaluation, so I hope to find out what sort of things didn't work out very well, and I hope to learn and hope to do a better job next year. Okay? So your questions are welcome. I had a good time. I'm glad I used Sage. I learned a lot of stuff, so I feel good about that, and I didn't hear any complaints. So great. Thanks.
Questions or discussion?
Yes, please.
Do your students take a proofwriting course before they take algebra?
They do.
Okay.
Years ago, we used to have a full semester course, mandatory for all math. Well, it's not mandatory, but almost everybody took that class. Math, physics, math, and science majors. If they want to go into calculus class, they have to have this. There's construction of real numbers. So Reed was very famous for that. It's a very abstract, very tough class. Anyway, physics department, chemistry department, they complain, oh, you guys should teach calculus first when we wanted to know calculus. So anyway, we changed it. So we teach freshman for one semester, we teach both differentiation and integration in one semester. In the second semester, which is mandatory for all math and physics majors, we have this course that focuses on foundations of mathematics. We start with what a field is, and then we define natural numbers in any field, integers, and then rationals, and then we write up we throw this additional axiom for real numbers and complete this axiom. So we spend about half the semester we spend a lot of time on just writing proofs.
Okay. Did you notice that Sage improved in this course their proofwriting ability throughout the semester in any ways?
I'm not sure if Sage helped in that regard. It may have, but I haven't noticed that. These students, most of them are juniors. They're quite good in writing proofs.
Okay.
Yeah. I mean, they basic proofs.
Okay.
Yeah.
Did you feel like the Sage work was on top of what normally would be taught, or do you feel like it replaced some of the things that you would normally cover?
I think Sage provided additional material. I didn't have to sacrifice any of the material that I wanted to teach. It didn't come in the way.
And workload for students? Did you feel like the student workload was more because of that, or do you feel like they spent less time other places?
It was a little bit more because they were asked to spend some time with Sage exercises, but not much more. It was reasonable, I thought. I didn't hear any complaints about having too much work with Sage. I would only give them 4 or 5 Sage exercises. First couple of them would be pretty easy. Yeah.
I'm interested to hear what the effect was of having this student TA, who's an experienced user. And what I'm particularly curious about is, so one of the things that comes up a lot when Sage gets used in the classroom is that the students who don't have prior background with Sage, which I guess was say half of your students, it can be hard to persuade them to put the effort in to actually get to use it. Did you find it helped having somebody, so to speak, at their sort of a peer that was familiar, that could show them how to use Sage?
Absolutely. I was very fortunate. It was wonderful to have the student who is there to help them. In fact, the student was willing to take email questions by email from the students. So some of them made good use of his services. That worked out quite nice. That was very fortunate.
So do you feel like you got better sort of usage response from the non-SAGE background students than you would have if you not had a?
I think so, yeah. Some of them were really new to SAGE, and they would spend maybe half hour or so struggling, and then they would immediately email this guy, I've come to see this guy during office hours, and then they were quite happy.
Great.
Yeah, that was really nice.
I guess it's kind
I'm
of
sorry
hard
you're
to-
graduating.
Well, find another one for next
Yeah,
time.
yeah.
It's kind of hard to separate whether it being a peer or whether just knowing more about SAGE would be more important, I guess, because Sam,
Yeah.
both of us.
Well, there's a possibility, it's one thing to have, a faculty member on call that you can ask, but a peer might be easier for,
More approachable.
it might lower the threshold for students to ask really trivial questions about SAGE.
All right, other questions? Okay, thanks a lot, Rao. Go ahead and refresh your snacks or whatever.